Alright, good afternoon, everyone. Welcome to MLDA Deep Learning Week Hackathon. So, a gentle reminder to all the judges that today this is judging criteria. Do know that you have to judge accordingly to this following criteria: technical accomplishment, impact of the solution, creative use of ML or AI, and polishness of the solution. And then for the finalists, all the best for you to win the first, second, and third prizes. So there will be scenario prizes such as the Best Junior Hack, Industrial Sustainability Award by Micron, Best Hardware Hack, most popular solution, as well as most socially impactful hack. So we had a mini game for our participants of the hackathon, and they have prizes to be won too. So for those participants, stay tuned. They who have taken part in the mini game yesterday, stay tuned and see when you know whether you win or not. And also for those who submitted for the this hackathon, you'll get a tote bag, laptop sleeve from Shopee, TikTok merchandise, t-shirt, and then for the finalists, you'll get AWS box. Yep. So right now, we're just making sure that the teams are being able to be the finalists and for them to share their presentation in a while. So yeah. All the best finalists.
Team 10, it's your turn. So we'll start the time now.
Hi, good afternoon. Hi, good afternoon. We are Team 10, Binary Bombers. So we are two year 3 NTU students, and our project is creating the COVID-19 chat box called BBBot. So our problem statement is COVID-19 has erupted in our highly connected information-rich world. However, accurate, up-to-date information about the spread, rules, and what we should do are hard to find and remains a challenge. With the increasing frequency of work from home, social distancing, and quarantines, going to a physical location to ask questions may prove to be challenging for some, and making phone calls to inquire for information may take a very long time and difficult too. So we decided to create this chat box to get an accurate answer. So we make this BBBot an AI-based chat box to help to answer COVID-related questions. So our chat box make use of TensorFlow because NumPy and NLTK to generate fixed replies based on what users are likely to ask. And our chatbot training model is used from IBM's list of most common COVID-19 questions. It also combines with common phrases and sentences to help train the model.
These will be the results that we get from the chatbot. So for example, on the left, you can see results that we get. When we ask the chatbot, when we say hello, the bot will reply, how are you? And when we ask questions like, I'm feeling sick, should I see a doctor? The chatbot will provide the proper response. But however, one of the problems that we face is that any statements not related to words related to COVID tends to break the bot. Like for example, the word chicken just causes the bot to not work at all. One of the potential improvements we see for our project will be that we can implement different languages, such as maybe Chinese, Malay, or Tamil, having a proper error handling, and a larger training set to reduce irrelevant replies, such as the one from the previous slide. We can also allow for short form and Singlish so that we can, for a more localized context. These are the references that we have used. We mainly use the developer for IBM for the exchange data, that one, the second link. We tried to use the first one where it's more of Singaporeans' SMS habits to make it more localized, but due to the time constraints, we are unable to do that. We also tried doing microtext normalization to allow for short forms, emojis, and other various type of chat in for the bot, but we are also unable to do that.
Your time is up.
Right.
It's 3 minutes already.
That's all for our presentation. Thank you. Do you all have any questions?
The judges, please, you can ask questions already.
Okay, so based on my understanding, you provide some automatic answer to the questions. Use the text question and answer the question with the text. I think there are some solutions already in the website. So your work, what is the difference of your work, and what is the novel part, and what is your solution in the technical part? So this aspect seems not quite clear.
Our main idea was to try to make it more localized, because what we noticed from the current available options is that if you try to type like Singlish or anything, it completely doesn't work. What we tried to do was to make that try to make the bot recognize Singlish and maybe emojis. That's why we tried to use the SMS habits of Singaporeans, but we are unable to do so also because yeah, we failed on that part.
Is there any more questions from the judges?
So can you mention one of name of the technique you used?
Technique as in what do you mean by, sorry, I don't get the question.
I think just now you mentioned that you use the platform of the TensorFlow, right?
Oh, so basically what we did was to make all the phrases that the users type, we try to shorten the word to their individual words. So for the learning model, then we use the lemmatization to change it to the simplest form. So such as the word maybe happy, the happiest, happy, and we'll just short form it, lemmatize it to the word happy, and then we'll let the training model take over and try to detect on what the users are saying and provide the proper responses.
This Adeline from Micron. I may have missed this chatbot. Is it just used on the internet, or is also like voice controlled? Does it recognize people's voice as well?
No, it's only text-based.
Okay.
Sorry.
We have time for one last question. If there's no more question, then I'll go on. Thank you, Team 10, for your presentation. Next, it'll be Team 19. Team 19, you can share you can share your screen already?
Okay, sharing now.
Can you guys turn on your camera as well?
You can't turn on. It's been stopped by host.
All right, your time starts now.
Okay, so dear panel, so our pitch today will be on the early detection of the elderly at old folks' home using computer vision on CCTV footage. Why are we doing this? This is because the elderly do move around on their own at old folks' home, and this could pose as a danger to them when they enter places that have lesser people like toilets or stairwells. So accidents like having a fall can happen, and early detection will be crucial in saving their lives. A similar situation happened before where an elderly man's body was found in the stairwell of a shopping mall only 3 days after he was reported missing. If he was noticed earlier, his life could have been saved. Therefore, our solution is to detect when an elderly enters and leaves an enclosed area using computer vision on CCTV footage. So if they enter an area for too long, an alarm is activated and a notification is sent through a Telegram bot to notify the nursing home staff. So this is a demonstration on how it's done. So the deep learning model will detect when the person enters the room. The time will start running then. When the person leaves the room, the time will stop running. And when the duration exceeds a certain threshold, it means that the person has been in the room for too long. So after the person has been detected to be in the toilet for an extended period of time, the software will ping a web server hosted on the Raspberry Pi, and it triggers the alarm and LED, as well as sends a message to the user to alert them of the situation. Here are the technologies used. So we use the YOLO V5 to detect the person, and Deep Sort is used to assign a unique ID to the person and track him across the frames. HTTP requests are then made to trigger the alarm on Arduino, and the Arduino processor then sends a Telegram message to notify the user. In conclusion, the social impact of our idea is that it provides an early detection of the elderly if they face any accidents, such as falling or fainting in the toilet. This is crucial as there will be a higher chance of saving their lives if they receive help earlier. In addition, this reduces the manpower needed for the nursing home staff to keep track of the movement of each elderly. With that, thank you.
Judges, you can ask your questions now.
Basically, what the critical sense is, you need to count the time, right? Start from the elderly into the toilet and up to the time the elderly come out. So the machine learning part is used for the person detection. Based on my understanding. Just now I say you have two boxes in the detected person. One is the whole person, one is the head or the face. Why you have the two? You only need to detect one is sufficient.
Yes, to answer the question, actually, yes, I agree, we only need to have one. But the issue is that as you are debugging the program, decided that you can have two, and we realized that the head actually detects better throughout the frames.
So you use is the whole body detection or the head detection or face detection. I'm not quite sure.
Currently, we are using the head detection. Yeah, so you're right, you only use the head detection in our case.
Okay.
I have one question. How do you know that it's an elderly face?
Sorry, may you repeat the question?
Okay, if you only detect the head, how do you know that it's an elderly face?
Okay, for this question, currently we did not distinguish between the elderly or a general person who is at the location. So what we want to detect is mainly the person who enters the room and hasn't left for a long time. So this may mean that the person needs help and someone should go in and check. So for the greater plan of our project, we plan to implement a person re-identification model. So you'll be able to identify the exact person who entered and left and match the records.
Okay, so yeah, here's a Bihan. So can I ask a question? Because based on just now Prof. Zhang and Prof. Cho's question, right? I feel like what you're doing is actually different from what you are proposing here. Because you can either, seems like you can neither detect for nor detecting elderly, right? So my understanding is that this is a very standard person, I don't know, re-ID or detection algorithm. Am I right? Or if I'm wrong, can you maybe justify a little bit?
Okay, so currently the way our model works is that it detects the person entering into the frame. So because we are targeting this product at locations such as, let's say, if the elderly were to enter a toilet, it's not feasible for us to install a camera in the toilet to monitor if they have a fall. So the best we can do is to monitor if they have entered the place and have not left after a reasonable amount of time.
Okay,
So
but
we do-
what happens if multiple people are entering the toilet and multiple people are leaving the toilet?
Ah,
How can you
okay.
tell who is entering, who is leaving?
Currently, we have not implemented this functionality yet. It's only able to recognize the single person. But throughout the course of our research, we have found several papers and repositories with the functionality of person re-identification. So we can assign an ID to that specific person in the camera feed and then track the same person and re-identify that person when he comes out of the toilet. So our future plan is to implement that and replace our current model.
Yeah, so that's exactly my point. I think you are solving the problem with the wrong solution, right? Person detection is very different from person re-ID. So if you are looking for person re-ID algorithm, you should look for re-ID baseline. What you're showing here, like YOLO or I don't know, whatever else you are using is not a person re-ID algorithm. So that's my suggestion. So you should kind of looking for right solution for the exact problem you're proposing. Yeah, so that's my comment.
Okay, sure.
Thank you, judges. I think there's no much time for Q&As anymore. So we'll thank you, Team 19, for your presentation. We'll now proceed to team number 20.
Oh, okay.
We have already enabled you guys to turn on your camera. So
hello,
please turn
yeah.
on your camera.
Yeah, I'm here. Hello. Okay, I'll share screen. Hold on. Allow me to share screen.
Okay, your time starts now.
Okay, is it clear? Like the screen here? You can see, right? Yeah, okay, I'll start. Okay, can. Good afternoon, everyone. I'm Jingwen. I'm currently from Team 20. So we come from a group of four members who are all like 4 year 1 NTU students, of which only 2 can actually code. So our pitch today, right, is actually a COVID-19 bot, essentially. So allow me to show a demo video of it first. Okay. So as you can see, right, it's a bot. Then what it does is that a user can input a message into the bot. Example, vaccine isn't dangerous. Then the bot will actually reply you to inform you whether the statement there is actually true or if it's false. So if it's true, it reply you that this is true. And if it's false, it reply you that this is a fake news. Okay, so here's like a rough example. Okay, I'll cut away here to my slides. Okay, so the problem statement we have, right, is that I think for the past 2 years in Singapore, I think we all know that there's actually an epidemic of fake news, meaning that there's a lot of fake news across Singapore, either in the form of like WhatsApp chain messages or like a Teddy chat group. So we identified that the largest source, right, of like the fake news is a Teddy chat group called Singapore COVID, whereby there's close to 20K members inside, and they share fake news, for example, that vaccines are dangerous, that they cause heart attacks and so on. And it creates an issue because if enough people think that vaccines are actually not effective, right, then those people won't go and take the vaccines. So in like a worst case scenario, it can cause them to suffer from death from like COVID essentially. So we solve this, right, by creating a bot. So how we made a bot is that we took the data sets, right, we exported the chat history from the COVID chat group. Then we use this to equate into a data set of false. So everything from the chat group is false. And then we also web scraped a couple of like the pages from WHO, as can be seen here, to be a data set for true. So we taught a model, right, a naive based model from sklearn. We fed the model these 2 data sets from like the Singapore COVID chat group, as well as the WHO page. Then we taught it to be able to identify whether a statement is true or false. Okay, so I can elaborate on like the exact way it's taught, which is that it uses a naive based model from sklearn. So regarding the impacts of this, right, we think that it can be helpful to everyone in Singapore because it's number one, easy to use and free. Like example, you might know that MOH had an Ask Jamie bot also. which was supposed to be able to answer public queries regarding COVID-19, regarding any queries they have. So we propose that this could be something similar to that in that use. Yeah, that's all I have.
Your time is up. Now
Thank
for the
you.
judges, you can ask questions to the team.
Hi, so this is Aaron from Micron. So yeah, I'm just curious because you mentioned your chatbot is actually targeting elderly. So we also know that for elderly do take some time to actually adopt new technologies. It's even for chatbots, I would say. So how would you actually try to then go ahead and convince the elderly or actually get the elderly to adopt this technology then?
Okay, so our target audience, right, to be more specific, is like the people who are already exposed to fake news through the forms of, like, example, the chat groups, like WhatsApp, for example, the chat groups like Singapore COVID, like COVID. So we think, right, that if you're able, like if you're tech savvy enough, right, to access those chat groups in, like, the first place, then you'll also be able to be tech savvy enough to access a chat bot. Yeah, thank you.
Okay, all right.
Is there any more questions from the judges? Okay, since I don't think there's any more questions from the judges, next we'll proceed to team number 27. And thank you, team 20.
Just now, what is the team number? Just now, this team number?
Team number 20.
Just now you had 20, okay.
And now let's welcome team number 27 to present. Can you share screen and open your camera? Because of time constraint, we won't be waiting for you, so we'll be starting your time in 3, 2, 1.
Can you wait for a little bit because I need to check screen.
Welcome everyone and esteemed judges to our presentation, Trash Purchaser, the Intelligent Trash Classification System. The question is, how long do we have left until the earth is covered in trash? The hint is not long. Singapore's Malacca landfill is expected to be full by the end of 2035. Recycling is the best form of trash management. However, it is still not the social norm. Current approach to this problem requires the user to think too much or too little. Too much is at the left, where the user had to actively think of which trash they're holding and throw it in the corresponding bin, or too little, they automate the entire process, hence creating little to no awareness about recycling. Our approach use human-centered design process to empathize with the user about what they think about recycling and their thought process when throwing a piece of trash away. We define a problem and come up with an idea to essentially make a guiding system to guide the user to the correct bin by lighting up the correct bin. So our solution is a computer vision-based model to classify trash and points the user to a corresponding bin. provide a response to encourage the right recycling habit. We prototype with ESP32 and 6 LEDs to represent the 6 types of trash. So when using the webcam, when the webcam detects what type of trash the user will holding, it will send serial data to the ESP and lights up the corresponding LED. The model results. We fine-tune the pre-trained ResNet to 50 model with the dataset with 6 characters from TrashNet, 6 categories of 6 recyclable waste: cardboard, glass, metal, paper, plastic, and trash. With an accuracy
your team's
0.88.
time is up, so now we'll proceed to the Q&A
This is the end of
by the judges.
our presentation. Thank you everyone for listening.
Okay, so thank you. Basically, you built up a classification system to use the computer vision method to classify the image into different class. So because the purpose of your system is to help users to provide the convenience of the users, then how about if the user somehow mix different class of the sense together, then what is your result of your classifier? Because your classifier must assume what your camera get is one class, one type of this sense, right? Of one of your class, but the user could mix some different sense together.
So we also thought about that problem before. One of the proposed solution is to detect multiple types of trash and light up multiple at once. However, we because of the 48-hour time constraint, we're only able to produce the one type of trash per images captured by the webcam.
Yeah, so what I suggest is you may need to have another additional class. It's a mixed class. If it is identified that somehow the sense contains many different types of sense, so you may somehow remind the user to separate them and then go past the system again. First separate. So you need first somehow identify if it is just one type of the sense or a mixed sense. Yeah.
This is Adeline from Micron. My question is, you are designing the sensor in a trash bin, right? In the recycle bin. And when we throw things, the movement of the object will be quite fast. How will your algo be able to quickly capture, detect, and classify it so that it goes into the right bin?
We intend to use ultrasonic sensors because I think when detected the object falling, there will be a change in data collected in the ultrasonic sensor, which showcase the fact that there's trash put inside. Do I answer your question correctly?
Sorry, you were saying that there's an ultrasonic sensor in the trash bin to do that image classification, is it? I mean, to capture the image.
Yeah, but currently, because of hardware limitations, we use in the design prototype, we use a small white button that represents when the trash is put in, it is pressed. So it's currently using mechanical power. So if when the light is lighting and the trash is put in, the light will turn off and there will be a blinking congratulatory sequence to encourage the user. Small button here.
Okay, thank you.
Thank you, Team 27, for your presentation. Now we'll welcome team number 30 to present.
Thank you, everyone.
It's 30 or 13.
It is 30.
Okay.
Okay, now team 30, your time starts now.
Good afternoon. We are team Into the Unknown. 60%. This is a prediction of how many Singaporeans might experience back pain in some point in their lives. One of the main culprits we know is actually bad postures. Let's use a moment to think how long we sit at a desk. It is 40 hours. This is how long we spend working in front of a computer in a week. We slouch when we read. We slouch when we write. And we even slouch when we work. The most upsetting fact is that we slouch all the time. Current solutions to combat bad postures are conventional postures correctors, but these might lead to uncomfortable after a long period of time. But now, let's take a moment to watch a short video to demonstrate our AI solution. Introducing Posture Reader, an AI program that saves your back. On the main page, a user can start by calibrating their own healthy and upright sitting position in front of any devices with a webcam such as iPads and laptops. Images will be taken at regular intervals using the webcam and passed into a machine learning model. A pop-up notification will appear if the user is having a bad posture such as slouching forward, backward, or having an unbalanced shoulder. Compliments will also be given to the user for maintaining a good posture from time to time. Posture Reader is designed to help users reduce any bad effects after slouching for long hours.
Sorry. Posture Reader is developed using an AI solution. We created a novel dataset based on real-life scenarios. 13 landmarks were extracted from the upper body using media pipe pose. On top of that, features like eye alignment and shoulder alignment are further extracted. We then built a new deep neural network to identify 3 different types of incorrect postures. Our model achieved high accuracy and recall rate, especially for detecting slouching forward and backward. When users sit in an unhealthy posture, Posture Reader would be able to detect and send reminders to our users.
We plan to develop Posture Reader as an application that's also runnable on mobile devices, such as phones and tablets. We would enable various different notification modes, such as voice
Your
reminders.
time is up.
And
it's 3 minutes ready. So now we'll proceed to the Q&A.
So you determine the posture of a person. So, but your webcam only capture the face and some of the shoulder. So is this information sufficient?
Our product is actually directing at a specific scenario of usage, which is when you sit in front of a computer and use the computer to work or to study. So that's why we will focus on the landmarks of the upper body posture.
Yeah, just now you mentioned that, but you didn't present which part of the body, which part of the landmark, or only 2 shoulders.
Yeah, with only the 2 shoulders and the upper body, the landmarks. And using our model, we see the result is quite acceptable. It's 94.1% and 87.5% of recall rate. So our model can quite effectively detect the incorrect postures with only the upper body landmarks.
Okay, it's quite good, although it's a little bit unbelievable, but quite good. Okay.
This reference point.
Yeah, and also we use on top of the 13 landmarks, we also extracted feature, for example, the eye alignment and shoulder alignment, as well as we calculate the displacement for the correct posture. Yeah.
Okay, quite good.
How many
hello.
data set do you
Oh,
have? Sorry, how many data set do you use to calculate your success rate?
Yeah, for data set, actually we have like let me calculate.
There's a total of 339 pictures, and this data set is a completely novel data set that we created on our own based on our real life scenarios of using computers in the age of pandemic.
Yeah.
So the
Wear the
reason
mask.
for not creating, the reason for creating our own data set is that there's no readily available data set out there, and we feel there's a need to like match our data set to our real life application scenarios.
Okay.
Hey, Bihan here. I mean, yeah, I think that's really good presentation. I like it. Also, I think that's a good. It's a good one as a business plan. I think that's a really fantastic one. But I have to say, from the technical perspective, I really don't have some enough detail to really judge, right? Like you said, data set as well as of course it's a novel data set, but the size may be limited. And also, you never mentioned what are the network you are using. And also, I mean, one hint, you know, as I'm also teaching undergraduate AI course. So when you connect the data, try more people and avoid overfitting to the ones you're training there. So yeah, that is my suggestion. But I like it as a business plan. Yes.
Yes, thank you.
Thank you.
We also realized the limitation of the size of data set. So the two things we've done is that first, we didn't use a very complex neural network such as CNN and RNN to avoid the problem of overfitting. The other is that I think I feel like when we develop the app, like full-blown app, and if we are able to collect customer data from our users upon their approval, we will be able to scale our to increase our data set, to help train the neural network better. Yeah, so these are the two things that we think we can do. Yeah.
Right, thank you, Team 30, for your presentation. Now we'll go to the 36, Team 36.
Test. Can you guys hear me? Test.
Yes, so your time starts now.
Okay. So we are Team 36 here to present our hack, Detox, manage a safer digital space. So let me tell you more about our problem statement. Toxic speak and hatred are tarnishing the value of online community spaces. Studies have shown that prolonged exposure to hateful content and messages affects your mental state. Today, there are approximately 4.66 billion people using the internet. 4.66 billion thinking, feeling, emotional humans spread across the entire world, speaking different languages. Humans who can be hurt by toxic content. We, Nishka, Swati, Siddesh, and Arumugam, believe that nobody should have their day ruined by an offensive message, by an inappropriate text, or by a hurtful comment. Our solution to the increasing toxicity of the internet is an easy to integrate web service that offers toxicity filtering to any web-based platform. We trained a multilingual model to classify and filter toxic content in your messages or web pages. Now, over to Siddesh for the rest of the presentation.
So with this solution, we aim to tackle cyberbullying in online forums and channels, and also video streams. I mean, there isn't any out-of-the-box API that's there that could be used by moderators to integrate into their community space. So our idea is basically to help moderators to maintain a safe community space. And as for our technical implementation, we faced our development stages into three parts. First was the model training and evaluation. We used a pre-trained XLM Robota model, and then we fine-tuned it for the toxicity classification. And we used a Kaggle dataset to do it. And as for the model deployment itself, we deployed the model in a AWS EC2 instance, and we added a load balancer to manage the traffic. Because since we get like a high volume of traffic from conversations, chats, we kind of implemented this as a way to manage the traffic. And in order to showcase our web service, we also integrated with Discord and also created an Android accessibility service. And let me just quickly go. So we created a Android app where it kind of scans your system and then it notifies you when you see offensive content. And as for the site itself, we have exposed our API to anyone so they can integrate with their platform. And you could try it out over here, and you get the thing. And as for integrating to Discord server, we've made this very easy. So you could just do it with one click, and then you get to add our bot with any of your servers. And with that, yeah. So with that, let me move to the future direction of our idea. So right now, it's just a web service which could be used by anyone.
Your time is up. We need to go to the Q&A session now.
Okay, yeah.
Is there any questions from the
Judges, do
judges?
you have any questions?
Because there's no question asked, we'll go on. And thank you, Team 36, for your presentation. We'll go on to the next team, which is Team 39.
Thank you.
Thank you.
Team 39, your time starts now.
Good afternoon all. We are Team Audio and we will be presenting our project. Did you know that 1 in 10 Singaporeans above the age of 60 suffers from dementia? This corresponds to approximately 82,000 people, and this number is projected to increase to 152,000 by 2030. Experts say that the best way to combat dementia is early detection, so that patients can take steps to slow down its progress. But nobody likes to go to the doctors, be it too expensive or just plain inconvenient. Because of this, many dementia patients only find out when it is too late. This is where we come in. Our team Audio has developed the Dementia Diagnostic Test, or DDT in short. First, we generate a logistic regression model in predicting how likely a user gets dementia. Our research suggests that dementia is affected by several factors like age, gender, and education level, just to name a few. In our app, users will input these factors for tabulation. Users also take the Mini Mental State Exam, MMSE. The MMSE is an international test used to determine an individual's cognitive ability, testing on reading, recognition, and retention. With the tabulated scores from earlier factors and scores from the MMSE, we can then predict the likelihood an individual gets dementia from our regression model earlier. Our solution impacts up to 300,000 recorded Singaporeans who experience their first symptoms, which is crucial with an aging population in Singapore. Additionally, a manpower shortage that COVID has made known, it frees up resources dedicated to such matters. Our regression model utilizes the 4 factors: age, gender, education level, and MMSE scores, as follows in generating a z-value. This z-value is then used to calculate how probable a user is in getting dementia. Our calculation has 85% confidence in generating accurate predictions of a user's likelihood in getting dementia. And to further improve our implementation, and in turn the confidence level of our app, we can extend our interaction with various organizations like Health Promotion Board and SingPass to retrieve information like MRI scans and socioeconomic status to produce a more accurate model. Here, we will showcase how our app works. First, we have a basic homepage. Thereafter, we have our initial inputs of age, gender, and years of education. Following which, the app conducts the MMSE, asking various questions whether the patient completes a number of tasks to determine his cognitive ability. Tasks like reciting objects and basic calculations, just to name a few. Finally, our results page will determine the likelihood the patient gets dementia. We strongly believe that the Dementia Diagnostic Test can help millions worldwide, as dementia is a very real problem. Until we find a cure, the best we can do is attempt to detect it as early as possible and implement preventive measures. Once again, we are Team Audio and we have come to the end of our presentation. Thank you.
Hi, sorry, this is Aaron from Micron. I have a question. So, what is the data set that you were trying to use to actually come up with this regression equation? I'm assuming that you are taking from the Singapore population.
So actually, we actually got this data set from Kaggle, and we have about approximately 300, over 300 data sets, data points. So that's the data set that we use. But we actually wanted to try to improve this data set. So a possible way of improving or increasing this data set is actually using the app itself or using data from Singapore. But unfortunately, we cannot get this data. So if we can get this data, we can actually improve the accuracy of our app.
I see. Okay, because so in that sense, the data that you were dealing with, this is actually sample data across the globe, or was it specifically targeted from a specific location?
It's actually from the US.
I see. Okay, so, right. So maybe something to, I don't know whether this is something that you have tested in Singapore, but I'm just wondering whether the demographics and the equation that would differ across different geographic locations.
So we have actually tested the app based on with some elderly, or rather with some family members, and our regression model is actually very accurate. Yeah.
Okay, all right.
Hey, can I ask a question? So you mentioned about MMSE. What is that? Maybe I didn't get it.
So the MMSE is actually an international test that tests individuals or patients to test on their cognitive ability skills. So the MMSE is actually a survey, or rather just a format of questions to ask the patients. So it includes various tasks, for example, naming any random 2 objects, recalling what is the date and time, completing different tasks like close your eyes. So for our app, how it works is that our app is supposed to substitute you going to the clinic, because if you experience symptoms of dementia, you go to a clinic with maybe your loved ones or someone who supervises you. So our app is also done with supervision, and during this MMSE, the supervisor could be your loved one, it could be a family or friend, or someone from the community center will be actually there to help tabulate the points. So for example, if within the MMSE, the patient successfully closes their eyes or remembers what is today's date, then the supervisor will input 1 point for that.
Okay.
Yeah, but to answer your question, the MMSE is basically a list of tasks as well as questions to help prompt the user's cognitive ability.
Okay, so just correct me if I'm wrong. MSE is more to test the person who is suffering from the problem, not say potentially they're going to have the problem, right?
MMSE is used as an indicator, not
indicator. Okay.
Yeah, so not so much as a test for those who already have it. Yeah, it also is used in predicting. So if a patient goes to the first consult, whether he or she has dementia, the doctor will administer this test first.
Okay, understood. So basically, for a person like me, if I have no problem with this MSSE, but still have the risk of getting into the dementia problem in the future, but I don't think this app works for me, right? You need to have some early, I don't know, symptoms or something.
Yeah, so our app actually is mainly catered towards those above the age of 60.
Okay.
Because for example, individuals like me and you, we are a bit too young for the data set to predict. And on top of that, there are a lot of things that are more heavily affected for people of our age. For example, genetics. Yeah.
Okay.
So our linear regression model only predicts up to from 60 to 98 years old.
All right. Sounds reasonable. Thank you.
Thank you, Team 39. Your time is up.
Thank you.
Now we will go on to Team 61. Okay, so Team 61, your time starts now.
Okay. All right. Good afternoon, judges. So today we're from Team 61, Dame Dani. We'll be presenting you the solution that we're currently doing, which is called Kaja. Okay. Sorry. Can you see the video?
No, we cannot see the video.
Okay, sorry, can you see down? Okay, good afternoon, everyone. Good afternoon, judges. Today we're from Team 61, Team Damelani. We'll be presenting you the solution that we've built. Okay. So the domain that we're currently looking at is in terms of personal fitness and training. So of course, everybody has their own goals, right? And then some people actually go to the gym. Some people do this thing in their home. But of course, there are problems to this. First one is, of course, going to the gym itself is now of a hassle, especially during COVID times. And some people actually are, they don't want to go to the gym because they're nervous that they'll be, judged by the others. So of course, this brings the second problem, which is injury. Because without a proper guidance, your exercises can actually cause injury if you don't do it properly. And last one is, of course, hiring a personal trainer is actually costly, especially in Singapore. So introducing our solution, which is Kaja. So the aim of our solution is to actually directly tackle the three problems that we mentioned previously. First one is to provide guidance with real-time feedback. Second one is to actually avoid injury due to these exercises. And finally, we aim to make it affordable. Okay, so how does it do it? Okay, well, when you are exercising, you're going to use this Kaja framework that we built, as well as a small hardware that has camera and Wi-Fi connectivity. And with a push of a button, the camera on the device will actually stream the camera data, and then the Kaja framework will actually be able to detect your movements using a post-detection model, which is actually open source called OpenPose. And the data from this is actually your joints and your extremities. And using this, we are actually able to check what kind of exercise you're doing. And we do this by using our own TDNN, time difference neural network. So instead of just analyzing pictures, this model can actually detect what kind of exercise you're doing based on your movements. And in turn, this data can be used to actually improve your exercise. So as of now, the framework can detect three range of motions, which is squat, dumbbell curl.
Your time is up. Now it's time for Q&A session.
Your purpose is to identify what kind of the sport, or is the sport exercised properly or improperly?
Yep, that's true. Actually, we have a demo here. So as you can see, the model detects the person's key points, which is joint and body extremity. And then we detect the joint angles and stuff like that to actually gauge your motion and to see whether you're actually doing the exercise correctly or not.
Oh, hey, Justin, just two quick questions. I understand this is more like a pose estimation or maybe skeleton estimation algorithm you're running, right?
Yep.
Okay, two questions. First one is, say, I mean, there are many work which can estimate pose, but how can you use that to evaluate when you say how accurate this exercise is? I mean, you probably have a ground truth or baseline,
right?
You can compare to just maybe share a little bit how you actually compare that. What's your metric? And another, I'm just curious. So you have some key point there, like you have some QR code pasted on your room. What's the purpose of that?
Oh, actually, for the QR code is nothing related to this project. It's just this is in my room, and we have another project running. So hence the article markers. So there's nothing to do with this project at all.
Okay, good.
Yeah. Okay. So as for the post detection, it's actually only one part of the project. So the other part is, of course, the TDNN, the neural network that we built, which actually takes the input data for this is actually the key points detected by the post detection model. And using this, the network can detect what kind of exercise you're doing. And then as for analyzing your motion, since we have the key points, the joints and the location of your body parts, can actually calculate things like the angle. So for example, when you're actually doing dumbbell curl, we analyze the movement of your elbow joint. And depending on that, we can actually gauge how well you're doing the exercise.
I see. So you have those kind of rules, right? You set up beforehand and use that to compare. Okay, just a quick hint. If you're using those rule-based, judgment, you probably need the person to stand in a certain direction, right? If some person standing in the wrong direction, probably your angle doesn't really count. That is my concern, but yeah. But I mean, better to understand that. Yeah.
Right. As of now, actually, we only have one hardware camera. Right? So the hardware we actually employ for this is a portable one, battery powered and connects via Wi-Fi. So as of now, there's only one hardware, but there's nothing stopping the Kaja framework to actually use more than one. For example, we can place the camera in different angles, so it can capture and compare, and actually it can mitigate this problem where you actually face different sides. Also, this hardware is actually very cheap. It's less than $7. And why don't we use phones? First of all, later on, there's actually plan for improvement. For example, to build an app for this, and the app will actually maybe connect to, for example, the hardware. So the hardware has the camera, right? So if we use phone for the camera, then of course the phone has to be far from you, and then you cannot see what's on the screen. For example, are you doing the exercise correctly? How many repetitions you've done, and things like that. So that's why we ended up with using a low-cost hardware for this. And of course, the other advantage is you can bring this hardware anywhere, and you can get more than one if you feel the need to.
Hey, Justin, this is Adeline. Just wondering, how do you detect the arms? Because I saw that there's a leg on the right-hand side that it didn't get detected by your algorithm.
Oh, right. For this one, actually, the reason the leg wasn't detected is because the video is cropped. So normally, if you, for example, for another range of motion that you can do with this, for example, the push-up, if the camera can capture your whole body, then it can also detect your leg. So for this one, you cannot even see knee and below. That's why the model doesn't predict that one.
Okay.
Thank you, Team 61, for your presentation. Now we'll go on to Team 66 to present.
Team, can we do a sound check?
Yep. So now your time starts now.
Hey, good afternoon, everyone. We are Team Daddy, and we are here to present to you our solution, Bushia. So Singapore is actually facing a problem, a very urgent problem, and it's the heat problem. Singapore is heating up rapidly and almost twice as fast as the global average. There are lots of negative environmental and social impact, but most importantly, if no action is taken, the average maximum temperature is poised to rise from 31 degrees Celsius to 37 degrees Celsius by the end of the century. So we have identified the main contributor, and that's the urban heat island effect. So what it means is that heat is generated from the humans, and they're all trapped at urban surface. And two key drivers for that is number one, excessive air conditioning, and number two, the lack of vegetation. Herein lies our problem statement. How do we cool Singapore sustainably in line with governmental efforts such as the Singapore Green Plan 2030 as well as Cooling Singapore initiative?
Now, our solution was to create Bushia, a visual advisory tool to allow building owners to visualize a hypothetical vertical garden system. This product will help illustrate the design impacts of such a choice with an AR overlay on the input image, as well as estimating the financial significance of such a system. Vertical garden systems cool indoor temperatures by two primary mechanisms, reflecting incident solar radiation, as well as evapotranspiration, which is the evaporation of water from plants.
As an advisory tool, Bushia helps to save money. Vertical gardens cool an interior by 6 degrees Celsius on average. And to achieve equivalent cooling, a 5-star efficiency aircon requires 3 times the maintenance cost. By identifying prime locations for green walls, Bushia helps to save the earth. Aircon contributes to 19% of total carbon footprint in Singapore, and each household contributes 1.4 tons of CO2 per year. And in contrast, Bushia improves air quality and cools spaces. So Bushia identifies optimal vertical greenery to save energy, save money in a sustainable way. And this is our tech stack. The front end is React Native on phones, the server is on Flask, segmentation model is OCR plus HRNet, train of facade datasets, and the back end is on Python.
And here's our app in action. An image of a building exterior can be captured using the inbuilt phone camera function. Alternatively, they can be uploaded onto the app through your gallery. Next, the user will have to key in the building coordinates, and this can be repeated for multiple images. Next, we'll send the results over to the backend for processing or trained models. And finally, yielding us augmented images of buildings with optimally arranged vertical gardens, along with a few other key metrics to identify cost and energy savings. With AI-powered Bushier, we can help you save energy and money through natural cooling and move you one step closer to sustainability. Thank you.
Okay, now we'll move on to the Q&A session. Judges, is there any questions?
I have one, but I don't know whether, okay, so how do you actually quantify the savings from your solutions actually?
Okay, I'll take this question. So we actually calculate this, right, by evaluating the amount of thermal energy required to cool an empty room by about 2 degrees Celsius, which is the estimated amount that the VGS will cool the temperature by. Now, this is of course reference to current research in the industry. Now, this is then again cross-reference to the efficiency of industry standard air conditioning to return the power saved by the product itself. Now, this is of course a low estimation of the energy that will actually be saved because we assume that the room is only filled with air. But this allows us to have more credibility because we are not overpromising on our actual solution.
So do you guys actually go in to validate this in actual real cases? Like for example, doing a temperature delta, I don't know whether that's possible as well. So I'm just curious as to whether you are testing in real life scenarios.
Well, we do not necessarily have the hardware to conduct these tests. However, the research paper that we used were fairly substantial. They conducted tests for a very long period of time, some up to a year, and then we used those to evaluate how well the model worked in return.
Okay,
maybe I can add on to that. Yeah, like basically like how we get the temperature change, right? And the savings is like we try to predict the temperature from the orientation of the wall through web scrap data and through like wall and like perhaps in the future like we can extend it to like a wall material classification because like thermal resistance, conductivity, heat coefficients matters lah. And I agree with you, like it'll be good to validate this model on real world data, but then like due to time constraints and data constraints, we're unable to do it for the past 2 days. Yeah. Thank you for the question, Aaron. Yeah.
Right, thank you.
Is there any more questions from the judges? Thank you, Team 66, for your presentation. Now we will go on to Team 67.
Yep. Thank you, Dennis.
Team 66, your time starts now.
So good afternoon, everyone. We are a group of NTU Year 1 students, Team YEPCAN. For our submission, we developed an image recognition model to detect pneumonia from chest x-rays. So the problem that we are trying to tackle with this model is the strain of healthcare resources following how COVID-19 is becoming the new norm and daily cases are high. So we decided to tackle the detection of COVID-19 pneumonia since almost 20% of COVID-19 patients get pneumonia from it, which has high chances of causing hypoxia, which is a strong predictor of COVID-19 mortality rates.
Yeah, so basically our solution for this problem is that we trained an image recognition model with normal pneumonia X-ray data sets that could potentially be used to detect cases of COVID-19 pneumonia. So let's have a closer review of our solution. So basically for this, we used transfer learning using a pre-trained model called Inception V3. So why did we use Inception V3? We used it because it has low parameters to ensure that this model remains lightweight, and it is also able to give us a reasonably good accuracy. So it makes it feasible to be deployed at healthcare institutions, for instance, for relatively fast and accurate classification and preliminary analysis. It also boosts a 93.94% accuracy in determining if a patient has pneumonia based on our test data set.
So what are our impacts for this solution? So firstly, it provides a quicker and cheaper initial diagnosis to sieve out higher risk COVID patients from those at risk. So this allows more efficient allocation of resources, as of course now Singapore is faced with our healthcare system is rather strained, and then a lot of the resources are can be put to more at-risk COVID patients to help save more lives. So then for future improvements that can be made, firstly, we can introduce image augmentation to test with other pre-trained models, example, ResNet, and to boost the model accuracy. So furthermore, having a better spread of normal versus actual pneumonia chest X-ray images will help to allow for better generalization of our model. Furthermore, using actual data of COVID-19 pneumonia to train the model in order for model to predict better COVID-19 pneumonia. So basically our model currently is using just the general pneumonia, but because of the lack of data for COVID-19 X-ray images, that can be improved on. Lastly, we can tune our model to also actually detect the severity of pneumonia and therefore the risk of hypoxia, which ultimately is an indication of how risky or severe the mortality rate will be. So this is an example of our code. So firstly, as you can see, this is an image of an X-ray with pneumonia. So by putting the image, we can better predict, for example, for this image is a 4% chance of being a normal image, whereas there's a 96% chance of being having pneumonia. So as a result, we can
your
print
time
out
is up.
Pneumonia
So
detected. Yeah, thank you.
Go on to the Q&A session.
Okay, I think this is somehow a very standard form problem to solve this image recognition or classification problem. So is there any somehow nuisance from your team?
Yeah, I think in terms of something unique in our team, I guess what we decided, we considered more towards how our solution will be more applicable in our context. So we tried to look at, firstly, how can we make the solution lightweight as possible and how accurate it can be. So I think it all depended on the choice of the model we used. I think we used Inception V3 as compared to other pre-trained models such as VGG and those, because it's lighter weight as it has lower number of parameters. So I guess the choice of our solution makes it unique in that sense. Yep.
Inception model are widely used in medical image, I think.
Beg your pardon, I didn't catch the question.
I mean, just now you mentioned that you choose the model, this so-called inception model somehow is your own word, but I think this inception model is widely used in medical image.
Oh, you mean use a pre-trained model for medical images?
Yeah, this inception model, just now you mentioned you choose this model. This model is somehow used in many different areas, especially in the medical image.
Yeah, I think for us, based on experience, we used this model before in other tasks. So we decided, we were curious to see whether we could just use the same model for this. And based on our accuracy, we were quite satisfied in the short amount of time we had. So we just decided to go with the choice of this model. But if we had opportunity, we would actually look at other models.
Is there any questions from the judges?
This is Jinghua from Micron. So, like just now the prof mentioned, this kind of problem statement is very common in current medical industry, and even if some review materials offer from some commercial company. Before you start this, have you explored and see what kind of additional features you can provide based on this solution, besides just the models and the images you're trying to solve? Any additional innovative things you're trying to achieve from this project?
To be honest, we wanted to actually look at the severity of pneumonia as well as we wanted to actually try and deploy the model onto a web application such that when we actually take a picture of the X-ray itself, it can help us to detect. But we didn't have we were constrained by time, so we couldn't actually implement that part. Yeah. So that's one part we would want to actually work on in the future.
Got it. Thanks.
There's time for one more question. Okay, thank you, Group 67, for your presentation. Next, we will have Group 69 to present.
Okay, Jeremy, when you're ready.
Your time starts now.
Okay, so hi everyone. Today, my group and I would like to present our AI/ML solution for sketch-to-face matching. Okay, next. So we are Group 69, and together we are the awesome foursome. Okay, so now to start off, let's take a look at this video.
There it is. Get a good look for yourself. Oh, and now I'm getting word that police actually caught this guy, thanks to the sketch, no doubt. So here's a picture of the real guy next to the sketch that led to his arrest.
Okay, so I'm sure you have seen police sketches like this, and you might think it's funny, which it is, but you will definitely not laugh if you are the one actually asked to find a suspect using the sketch. So what's our intended outcome? So our team decided to leverage on AI/ML to actually allow easier identification of potential suspects based on basic sketches. So our solution will be used to supplement the investigative process, such as the location of crime and other descriptors of the suspect, such as the age, race, etc. Okay, next.
And here's our project outlook. There are two different branches, the data image path and the user input path. Next. Next. For the image database, the first step is to denoise and normalize the data by grayscaling and using a min-max scaler. Then we carry out image augmentation on a set of sample photos and sketches. Our augmentation techniques generates about 200 images per photos, giving us 34,000 images to work with. Finally, we resize the images to a standard dimension. Then we run the images through a scale invariant feature transformation, aka SIFT. SIFT helps us identify key points and descriptors of contours, edges, and corners, extracting meaningful information regarding facial features using the result of difference of Gaussian. Now, look at our input path. Users will provide hand sketches as input data. The sketches will then be run through a generative adversarial network to generate a facial image. This image will then be fed into the SIFT algorithm to extract defining facial features like we did for our image database. Finally, let's look at the matching algorithm. Now that we have the feature points of both the input sketch and image database to compare between, we can utilize k-nearest neighbors, which calculates the Euclidean distance between each pair of multi-dimensional data points to identify the best fit image for our sketch. And that's how we can use a rudimentary sketch to identify the best fit image from our database.
So this is a showcase of our model. As you can see, the model will take in the image of our sketch, run through pre-processing and extraction of its features. Features of the sketch and the actual facial database will be compared, and the model will match a face that best fits the sketch. One example we have tried is to feed our own sketch of model 63. The model was able to successfully match the model 63 from a rudimentary sketch. However,
your time
our
is
model
up.
is not perfect yet, as most matches will lean towards.
Your time is up, please. We'll
Thank you for
proceed
your
to the
attention.
Q&A.
So the project try to match the natural image and the sketch. So this one is possible, but somehow you use the approach, use this key point, this SIFT point. I have some doubt because from the sketch, the key point is very less than the natural image. Because usually if we sketch human's photo is only consists of the ages and many ages. But in the natural image, it will produce a lot of key points. So the key point between them, I think it could be quite different. So why you choose the key point as the feature to do the match?
So to make it much more accurate, we actually use the gun to generate a facial image from the sketch, because we feel that a sketch may be too simplistic and it won't generate sufficient key points. So by generating the facial image using the gun, we can better compare the facial points and the feature points, sorry, between the sketch and the image database.
Okay, so you detect the key point from the generated image, not directly from the sketch, right?
Yes, correct.
Okay, okay. But still, because the GAN can generate the image similar to natural image, should be no doubt, but somehow it cannot generate some very identity-specific feature from the GAN. Yeah.
Yes, we can't generate the identical image, but the best we can do is to suggest the highest probability pictures that best fit our description. Yeah. So the idea is to have a couple of images, generate a couple of suggestions for each sketch. Then the user can sift through all these pictures manually. So it really narrows down a lot from maybe millions of pictures to just 5 pictures that best fit the sketch. Yeah, so while it's not perfect, I think it's a very feasible solution.
Okay, thanks.
We still have time for one more question. Is there anyone? Is there any questions from the judges? Thank you, Group 69. Now we will go on to Group 70 to present. Your time starts now.
Yeah, good afternoon, everyone. We are Team 70, and our project is about sign language on the edge. So what is the problem? Well, we've identified that the sign language community is underserved in healthcare. So how can we improve their accessibility and contribute to UN's development goal of reducing inequalities? So our target audience face language barriers, lack of interpreters, and limited access to healthcare. For them, overcoming these barriers is not just a matter of therapy, but equality as informed patients, unique individuals, and full members of society. I will now explain our solution. So we've utilized 2 machine learning libraries to process the video feed with media pipe converting, next slide please, converting hand gestures to machine readable array and then inference for the exact word using an LSTM model. This shows an overview of our proposed MLOps pipeline for the automated training, deployment, and retraining of our model. It utilizes a serverless pipeline for CI/CD and a SageMaker pipeline for training. The trained LSTM model is then automatically deployed to all edge devices. Users can contribute to the model using a web interface that allows them to capture videos of them themselves doing signs, which they can upload to S3 for the SageMaker pipeline to retrain. So this is our go-to market deployment. So we will use AWS to train, store the model, and deploy using AWS IoT. There will be deployments in the form of edge devices available at healthcare institutions, as well as integration with the Zoom SDK to translate live video. Lastly, the video UI allows for crowdsourced enhancement to the model list that we will use to continuously retrain the model and enhance its capabilities. So the use of AWS allows us to quickly move it to production deployment and continuously improve the model at lower cost.
Now I'll be talking about the impact. So this solution has both social and economic impact. In terms of social impact, our solution tries to increase the inclusivity and accessibility of healthcare services towards deaf-mute, especially in times of occupancy where a lot of interpreters might not be available. In terms of economic impact, we see a rise in aging population and the use of telemedicine becoming part of the new normal. So we know that this service will actually grow in importance around the world, and we can actually scale this through a subscription model worldwide. So to sum up, our solution can actually reduce the time of consultations, which helps with the cost of patients. And in terms of market, there are 70 million people using sign language worldwide. So this is actually a large addressable market being overlooked at the current pace of development. So now I'll be showing a demo.
And our Raspberry Pi right now is hooked up to speakers and a Raspberry Pi camera for input. So for example, if I sign no.
No. True. Steady.
Yep. And that.
How are you feeling? How long has it been?
Your time is up.
And
thank you.
So now we'll go on to the Q&A session. Is there any questions from the judges?
Oh, hey, Bihan here. Maybe a quick question. I guess maybe you mentioned this, but I somehow maybe I didn't get it right. Oh, okay. Can you explain more about the mechanism of understanding these gestures? Like, because I see in your demo you have some key point detection. Yeah, maybe you want to just explain a little bit more. Maybe I couldn't get the every detail.
Yeah. So first we have our solution has two steps. So one is the key point detection that we leverage MediaPipe. So if you go to that UI slide. MediaPipe allows us to detect the hands, pose, and face key points that will help us accurately translate, interpret what the people are trying to say with their sign language. And then after that, we use these key points. These key points are recorded and used to train a LSTM model. So our LSTM model has 3 layers to make sure it's fast to predict and it's lightweight so it can be deployed on the edge. So this LSTM model will remember the sequence of actions. So when you perform the sequence of actions in front of the camera, the MediaPipe will capture the key points and feed it to the model. Then the model will be able to predict what you're trying to say. Yeah.
I see. So then how many actions you predefine in your task?
So because there isn't a very big, there isn't a data set out there for us. So we trained our own data set. So for our demo, we did 8 action with 100 videos, each at 30 frames per video, and with 200 key points per frame. Yeah.
I see. Thank you. Yeah.
Yeah. Thank you.
Is there any more questions from the judges?
So in your database consists of the RGB video, so the key points are detected by yourself or provided by in the database?
So our database doesn't consist videos. What we record is just the key points. So we don't record any video. We just take into the points of the movement of key points across the screen. So in this case, in production, the benefit of doing so is that the community can contribute to this whole big database of key points without having to worry about privacy because no video is recorded.
Yeah, the key point is provided in the database. It's not detected by your machine.
Yes. Yeah, it's not detected. We use the key points to make the predictions.
Okay.
Yep.
Thank you, Group 70, for your presentation. Now we'll go on to Group 71. Okay, Group 71, your time starts now.
Hi, we are the team behind Project Cactus. Now take a look at these 3 news articles. Can you tell which is real and which is fake? Harder than you think, right? The line between the real and fake has now increasingly blurred and fake news has become more and more prevalent. Why? The internet, mobile device, and the social media platform are making information more accessible than ever, but at the same time, making news articles more indistinguishable with just a naked eye. Fake news has been spreading like a wildfire, especially so when the panic-inducing COVID-19 joins the table. the fire has become bigger and spread even faster. And that is where Project Cactus comes to save the day. Project Cactus is a multi-platform AI fake news detector that is accessible through the web extension, mobile, and PC through the progressive web app. Think of Project Cactus as a fire extinguisher to this blazing fake news fire. We are not just any fire extinguisher, but a powerful one. Our NLP AI solution utilizes the LSTM architecture that is trained over 62 data points from various data sets. And now let's take a closer look at how Cactus works.
All right, so with just a switch of a button, users can enable this extension, which will run in the background. Each article is then verified using artificial intelligence, which then alerts the user whether the article looks safe or fake. So this provides a user an avenue to think twice before sharing. In addition, if the prediction is wrong, the community can easily help report the issue. So this enables our AI model to stay relevant, which is lacking in many AI models.
Alternatively, users may use our web application to verify and check if a piece of headline is real or fake. During a heated debate, they can also choose to share the results or report an issue if they feel that the headline is wrongly classified.
So what makes us special is that we are a trusted and convenient avenue for fake news. So the users can verify whether the news are fake before they do what's right, which is to share. So imagine sharing a wrong news or a fake news and it causes mass hysteria as well as cause fear. So that's what we want to prevent. And last but not least, we want our project to be sustainable and community-driven solution. So as you have seen, that we allow the users to report, this allows our AI model to stay relevant and sustainable. So this is what Project Cactus is, and that's all.
Thank you.
So now we'll go on to the Q&A session.
Hey, I'm behind here. I'm just curious. What's your definition of fake news in your algorithm? I mean, I'm a little bit confused.
As for now, the definition of fake news depends on ultimately the data set that we fed into our model. So at the current moment, we are sourcing our data set online, and we have gained right now we are utilizing 4 different data sets, and some of them are especially in the context of COVID-19. So one of the famous data set is a fake COVID as well as a COVID-19 rumors data set. So as the final guideline to deter any the fake news from further spreading.
So yeah, of course, I mean you limit the scale. That's fine. But say just the data set you're mentioning, right? The COVID-19 data set. What's the definition of fake news? How I mean, can you share maybe more about your metric?
So basically, if a news is verified by a large international audience, that is considered not fake news. But if let's say it's just some random comment without any facts or evidence to back this point, then it's fake. So that's
So it's based on voting. Majority of people think that's true. That's true.
I guess in some way.
I believe as for the ultimate matrix behind what is defined as true or what is defined by false, it's easier for me to give an example that from our data set. So our data set that we use is a COVID-19 rumors data set. So what this data set is sourced from is by I believe going through all the Twitter's headline, and afterwards the experts have given a classification, assign a unique class for different headlines, so as to define whether the news is fake or not. So for example, a good example that I have right now is something like the health expert has predicted the virus to kill more than 65 million people in a year. So ultimately this news is something that is unverified, and hence it is classified as a false. But as for something that is more relevant, like for example, COVID-19 is a so in general, it's not just based on voting, but it depends on the data set that we have right now.
Yeah, so my question is, in your data set, what do you mean by fake news, or what do you mean by true news? So based on your explanation, that seems like an expert system. You have a bunch of experts who have the right to define the right source. Is that true, or is it the other way around? Because your teammates say that's voting. So these are two different ways, or two different type of definitions. So I just want to understand, what's your definition?
The definition depends on the experts sourcing of the data set. So it's not just purely based on voting.
So it's not voting at all. It's
it's not voting
system.
at all. Yeah, the expert defines the data set.
Okay. Okay. Thanks.
We have time for one more question. Are there any questions from the judges? Okay, thank you, Group 71. Now we'll move on to Group 77. Okay, Group 77, your time starts now.
Good afternoon, judges. We are team randomized, comprising of Paul, Mazen, Kenny, and myself, Fabrian. And today we'll be presenting our solution, iCare. Firstly, our problem definition. The prolonged COVID-19 pandemic has taken a toll on global mental health, leading to sharp increases in stress levels, depression, and suicidal tendencies. Hence, we aim to build an AI-based solution to improve mental well-being amidst the COVID-19 pandemic. Hence, introducing our solution, iCare, an integrated self-care journaling mobile application that seeks to improve mental health well-being powered by NLP to track users' emotions and mental health progress. Here's an overview of our architecture. Powered by NLP, iCare is able to identify potential depression and suicidal tendencies and direct users to seek the appropriate mental health assistance, whether it's connecting them with a mental health hotline or a support network. Now I'll be passing the time over to Paul.
Our NLP algorithm first extracts data, followed by pre-processing. Next, we perform feature extraction based on word frequency and classify the emotions based on random forest. Next, iCare has many key features as shown. Firstly, we have the integrated journal, which is a safe space for users to express and log emotions. NLP classifies the emotions and displays them in the emotional tracker. We then have a support network through messages and a chatbot to offer support to users. Lastly, we also have a smart notification system to offer advice when NLP identifies potential depression or suicidal tendencies. Following that, we have three main impacts of iCare. Firstly, iCare provides a quick identification of mental health issues. This allows for early intervention, as iCare will prompt individuals when negative emotions are detected and provide support for the user. Secondly, iCare provides timely assistance for individuals suffering from mental health issues. This is done through many ways, such as a carol carry system, a chatbot, smart pop-ups, and peer support through messaging. Lastly, iCare also increases accessibility and awareness of mental health. iCare provides an alternative avenue for people through the form of a journal to express themselves and to seek mental help. Now I'll be handing over my time to Tianyi.
Now I'll be showing you the demonstration of our app. This is the app journal page where users can see their previous journal entries and start new journals. Once new journal entry clicked, user is directed to integrated journal to enter their journal, and iCare will apply an NLP model to predict their emotions. This is the emotional tracker where user emotions over the past few weeks will be displayed by emojis. When our NLP model predicts users to have negative emotions, smart notification pop-up, including motivational messages, will be shown. When concerning journal entries is detected by an NLP program with suicidal tendencies, support hotline will also be triggered. Now I'll pass the time on to Mazen.
So our application provides peer support for those who require it. Whenever the system detects that someone in your peer support group is feeling down, it reminds his group to check in on him. Next, we have a
Your time is up.
Now
we'll proceed to the Q&A session. Is there any questions from the judges?
Your data is somehow the text input by the user in the chat box. Chatbot is just based on this text information. Okay.
So I think one means is, yes, through the conversations, past conversations, as well as the user, we also based it on their existing journal entry. So it's a multi-pronged approach. It's not just based on a single text or a single anything. So it's based on journal as well as a chat messaging together with a potential, the chatbot history.
So somehow this is related to somehow this sentiment analysis.
Yes, correct. It's related to sentiment analysis.
Okay, thanks.
Yes, I mean, I totally agree with Prof. Zhang. I think, yeah, I mean, there are some open challenges on sentiment analysis. You can probably find that in Kaggle, but my feeling is that the sentiment analysis may be slightly different than, mental issue. I mean, somebody can be sad and, for a while, but he may not have the mental issue as a proper, illness, right? So I'm just curious, like, are you using a specific data set, or are you just linking the emotion to a mental issue? Because this seems different to me.
There are certain keywords we classify as suicidal based on the past entries, and we have a whole data set based on suicidal tendency as well as just emotional data from the user input. So if they have long-term depression or certain, we'll just show them like motivational message and provide them with the hotline as well. Because if they undergo long-term emotional downturn or depression, they may actually also need to seek help, even though they don't have suicidal tendencies.
Okay.
And we also understand it's very difficult for an individual to display their suicidal tendency in such a way. And it's only possible maybe in the journal when they see something more private, they may actually show some tendencies, some words with that effect. So we'll just try to provide help to these individuals before anything actually happens.
I think ultimately the purpose of journal entries is like we will look at historical data. So it's not just also on a particular journal entry, but like over time, like what's the emotions of the person? Because we are using one data set on like more of the classification between suicidal and non-suicidal, and another data set for the emotional aspect. So combining these two together, we're able to give like a more holistic classification of and on whether they are more likely to be needing help.
Okay, thank you, Team 77, for your presentation. Now we'll go on to Team 88. Okay, Team 88, your time starts now.
Hi, I'm Amelia from Group 88. My teammate Marcus and I will be presenting on our project OpenSign. I'll be sharing about our problem statement, our target audience, the tech stack used, features of our product, and future implementations. For our problem statement, there is a lack of sign language literacy in Singapore, despite there being 500,000 people with hearing loss in Singapore. There are few willing or able to accommodate for those hard of hearing. For our target audience is youths and young children. While learning sign language benefits people of all ages, our main target audience is young children, in which learning sign language can help with cognitive development, and users can also reap the benefits of learning a non-verbal language. For our tech stack, we used OpenCV to capture images for our dataset and labeled image to create the labeled images. We then used transfer learning with TensorFlow to create our model to detect the various hand signs in the images. We then used Next.js and TypeScript to create and style the front end. For the features of our product, we aim to create two main features, one for learning sign language and one for the users to test their knowledge of sign language with the guidance of our AI. We managed to train an object detection model to detect sign language alphabet, as well as one with action detection to recognize a few signs with hand movements. However, due to the lack of time, our front-end website is incomplete. For future for future improvements to our website. Firstly, we hope to add a larger database of signs to train our model on, specifically for Singapore Sign Language. Another important improvement will be the model accuracy, which can be improved with a larger data set, as well as more steps in the training process, which we have limited due to the time constraints. We also intend to add soundless video call for users to practice sign language communication with others without audio available. Additionally, we plan to add user profiles to allow users to track their progress and share it with others, competitions to challenge their memory and speed of recall of the signs and meanings, as well as community features for users to learn sign language together. That concludes our presentation. Thanks for your attention.
Now we'll go on to the Q&A session.
So the project seems is somehow a standard project for the so-called sign language recognition, right?
Yeah.
Yes.
Okay, is any somehow specific sense in your project besides the general sign language recognition?
So actually one of our main aims of our project is to be able to create a sort of local experience for different local communities of sign language, because there are different variants around the world. And for us, we chose to start with Singapore. So actually in the action recognition part, you can see some of the Singaporean words that can actually be recognized. Yeah.
Okay, so your sign language is fixed or not fixed. Maybe for a same meaning, different person may show different action or different sign. So can you somehow generalize that even for different person with slightly different sign or action where you can recognize to a same meaning?
For this, we are hoping to. So actually, one of our future improvement is to have users who are experienced in their own local communities to provide training data, so that the different nuances between the hand gestures will be able to recognize it like the same word. So unfortunately, because we don't have much data set of the Singapore sign language, like the images or videos in general, we have to come up with our own recordings.
Okay. How many hand sign can you recognize now?
We tried on 5 so far, but I'm pretty sure we can continuously add on gestures.
Here you only show 3, right? And also the number.
Yes.
Okay.
Is there any questions from the judge again?
So from this example, it seems you use this skeleton image to detect this key point and link them together, right? This is called skeleton. Your feature is based on this skeleton to do the recognition.
So actually, the model will make use of not only the facial features and the hand gestures, but also a bit of the pose landmarks. So all this is included in the to be detected by the model.
Okay.
Because for some more complex hand gestures, especially in different local communities, we have to take into account like their facial expressions, not just the hand gestures.
There is time for one more question. Is there anyone who wants to ask? Okay. Thank you, Team 88, for the presentation. And this concludes the presentation for the finalists. And with that, I want to thank all the finalists and also the judges for taking time to come to this event and help us judge the finalists. We'll be opening another Zoom call so that if you want to discuss, you can discuss, but it is not compulsory for you to join this discussion. We'll be sending the link in the chat to the host and panelists. And for the attendees, come back to the Zoom webinar at 5:30 as we will be having a closing ceremony to tell you who wins the prizes and who is the winners of this event. And with that, we end the event already.